Today what we're going to do is we're going to take what we did the other day about using the distance, slope, and midpoint formula to show that a quadrilateral is a parallelogram. And now we're going to show that, this quadrilateral is not only a parallelogram, but also maybe a square, a rectangle, or a rhombus using the properties that we've talked about before. So remember, a quadrilateral is a rectangle if it has 4 right angles. We can also say congruent diagonals, because when we classify these things, we're going to be focusing more on the diagonals. So a quadrilateral is a rhombus if it has perpendicular diagonals, and a quadrilateral is a square if it has perpendicular diagonals and congruent diagonals. So in this example down here, we need to fix a misprint. It should be a 0, not an A. 0, because a y value is the same as its w right here. So this should be b comma 0. So what we're going to do is we're going to show that the diagonals bisect each other. So we're going to do the midpoint of this line. So the midpoint of xz, because remember, if the diagonals bisect each other, then they should have the same midpoint. So we're going to find the midpoint of the diagonals. So we're going to add the two x's. 0, x1 is 0, x2 is b, and then y1 is a, plus y2 is 0 over 2. So that gives me a midpoint of b over 2 comma a over 2. Now we're going to do the exact same thing with wy. So the midpoint of wy is, let's see, x1, y1, x2, y2. So 0 plus b over 2 comma 0 plus a over 2, and that's going to be b over 2 comma a over 2, and they're exactly the same. The two diagonals have the same midpoint, so they bisect each other. So we already know that this is a parallelogram, because parallelograms have diagonals that bisect each other or have the same midpoint. So based off of that alone, we know this is a parallelogram, but we also want to show that this is a rectangle. A rectangle has congruent diagonals. So now we're going to find the distance of xz. We're going to do the distance formula. We already have our coordinates labeled, x1, y1, x2, and y2, so we can just use the formula. So b minus 0 squared plus 0 minus a squared. And what that's going to equal, b minus 0 is 0, so we have b squared, plus 0 minus a is negative a squared. And like we talked about the other day, negative a squared is just going to be positive a squared. Oops. So the length of xz, the green diagonal, is square root of b squared plus a squared. And we can't simplify it any further, so we're going to leave it alone. Now we're going to find the distance of wy. Okay. So the length of wy, or the distance between w and y, we have x2, b minus x1, 0 squared, plus y2, a minus y1, 0 squared. B squared minus 0 is b. A minus 0 is a. So we have b squared plus a squared, and you can see that these are exactly the same. So we know that the diagonals are congruent. Now, like we were talking about with the properties of rectangles, yes, the diagonals should be congruent. We've shown that. Yes, the diagonals should have the same midpoint or bisect each other. We've shown that. But what if this is also a square? Because a square has perpendicular diagonals as well. So we have to then look at the slope between the diagonals to see if they are opposite reciprocals. So let's do that. Go back to my purple. So the slope, little m, of wy, it's y2 minus y1, so a minus 0 over x2, which is b, minus x1, which is 0. So the slope of xy, the purple line, is a over b. Now let's find the slope of the green line. The slope of xz, y2 is 0 minus y1, which is a, over x2 is b minus x1, which is 0. So we have negative a over b. Now those are opposite slopes. One's positive, one's negative, but they're not opposite reciprocals. So these diagonals are not perpendicular because their slopes are not opposite reciprocals. So this shows us that, yes, this is a parallelogram because our diagonals bisect each other. They have the same midpoint. Yes, our diagonals are congruent. They have the same distance using the distance formula, but they are not perpendicular because they do not have opposite reciprocal slopes. So up here, like we're saying, the rectangle has congruent diagonals. Now, on this page, when we have a square, we have a few more misprints to fix. This should be c comma c and c comma 0, because in a square, all the sides should be the same. So we're going to prove that this is a square by finding the length, the midpoint, and the slope of each diagonal and compare them. So a square is perpendicular diagonals. That means we're going to use the slope formula. So the slope of, we'll do wy first. So x1, y1, x2, y2. y2 is c minus 0 over c minus x2 minus x1, which is also c minus 0. We get c over c, or 1. Now we're going to do the same thing with the slope of xz. So y2, 0, minus y1c over x2. This probably helps. Over x2c minus x1, which is 0. So we get negative c over c, which is negative 1. Those are opposite reciprocals because remember, 1 can be written as 1 over 1. Negative 1 can be written as negative 1 over 1. Those are opposite reciprocals. So that means those two lines are perpendicular. Now, that doesn't tell us right away that this is a square because a rhombus also has perpendicular diagonals, and so does a kite. So just based on letter A that we just did, we know that this has to be either a kite, a square, or a rhombus. If it has congruent diagonals, if we show that this has congruent diagonals and that the diagonals bisect each other or have the same midpoint, then we can say that this is a square. So now let's do this part. Let's see that they have congruent diagonals, which is the distance formula. And luckily we have our points listed already. So the distance of xz is the square root x2 minus x1, so x minus 0 squared, plus y2, 0 minus y1, c squared. And like we've done before, whoops, this is not x, this is c. This is going to be c squared plus 0 minus c is negative c, which is also going to be c squared, which is equal to the square root of 2c squared, which is equal to c times the square root of 2. Don't be concerned too much if you can't go from here to here, because we just want to see that the diagonals are the same. So if we get this, we can see that they're both the same. Now we're going to do the diagonals of wy. So y2, x2, which is c, minus x1, which is 0, squared, plus y2, which is also c, minus y1, which is 0, squared. This is going to be, and now I can zoom in since I've written the coordinates down. This is going to be c squared plus c squared. And you can see that this is what we had up above. So 2c squared, or c times the square root of 2. The diagonals are congruent. So that means this could be a rectangle or a square. And the last thing we have to show, let me highlight those things. These two are congruent. So the last thing we have to show is that the diagonals bisect each other. So we're going to do the midpoint. So the midpoint of wy we add the two x's, so c plus 0 over 2, comma, we're adding the two y's, c plus 0 over 2, which is going to be c over 2, comma, c over 2. So this is why I was stressing to you guys the importance of knowing the distance and slope and midpoint formula so that you can do these quickly for these problems here. If you're still struggling with the distance, midpoint, and slope formula, then you've got to go back and get better at it, especially with these variable coordinates. All right, so add the two x's. 0 plus c is 0 plus c over 2, comma, adding the two y's, c plus 0 over 2. That's going to be c over 2, comma, c over 2. So that shows that the midpoints are the same, which means the diagonals bisect each other. Now, I understand that with the variable coordinates, it can get confusing. We're going to be moving away from that soon, but we're just showing that in a square, these three things are true about their diagonals. Now what's going to happen the next time is that I'm going to give you some coordinates and say, hey, which shape is this? And you're going to have to do the distance, midpoint, and slope of all the diagonals. So we're just kind of proving that this is what should happen in a square and in a rectangle. Up here we did a rectangle. Now we're going to classify shapes tomorrow. So thanks for watching. Make sure to like the video and subscribe.